Greetings everyone and welcome. So today we have 2 exponent x plus 2 plus 2 exponent x minus 2 plus 2 exponent x is equals to 42. What is x? To see how to find the value of x, watch the video till the end. So remember one of the laws of exponent: whenever you have the single base with 2 exponents, you split it in a form of, or this is 2 exponent x times 2 exponent 2 plus 2 exponent x times 2 exponent minus 2 plus 2 exponent x is equals to 42. Notice each term in this equation have 2 exponent x. 2 exponent x is common. We'll take it as a common factor. 2 exponent x, then here it's 2 exponent 2 plus 2 exponent negative 2 plus 1 is equals to 42. 2 squared is 4 plus a base with a negative exponent. The inverse of it is 1 over that base with a positive exponent. So now we'll write this in a form of 1 over 2 exponent positive 2 plus 1 is equals to 42. So the sum of these numbers is 21 over 4 equated to 42. In this side, we want to have 2 exponent x, so we need to multiply with the reciprocal of 21 over 4, of which is 4 over 21, both sides. Then 2 exponent x is equals to, the products of these numbers is 8. 2 exponent x is equals to, the 8 in an exponential form is the same as 2 exponent 3. The base are the same, we equate the exponent, so the value of x is equals to 3. Now this is the value of x. If you can take this 3 back into the equation, whether it's x, you will get the value of 42. So it means x3 is a perfect value into this equation. So sometimes if you get to the exam and find this kind of question, you have a root exponent, root x plus 5 is equals to 14 over root x plus 5. Then you ask yourself, how are you going to solve the value of x in this case? Because of these roots, maybe you'll be wondering and stuff. But now if you just can check, the roots x plus 5 is in the left hand side, again the root x plus 5 is on the right hand side. So if you can just say, let's just make the roots of x be one thing, like maybe big p, and then and see how are you going to do it. So let's just make it and see how are we going to find the value of x. So where there is root of x plus 5 will be p. So yes, substitute p plus 5 is equals to 14 over, where there is it, we said is p. Then we have the fraction into the equation. So we know how to solve this. With the denominator, we'll have the RCD, of which is the lowest common denominator, is a p. Then we multiply the entire equation by the denominator of p. So it's p times p, of which is p squared. 5 times p is positive 5p is equals to 14 over p. 14 over p times p will be 14. Then now it looks like a quadratic, as the exponent of, as the highest exponent is 2, so it means it must be equated to 0. So we minus with the 14 in both sides, so we'll have p squared plus 5p minus 14 is equals to 0. Look for the factors of the equation, whereby the factors of p squared are p and p. For factors of negative 14, that will give us the sum of the positive 5 are 7 and 2. Then the 5 is positive, it means the biggest number must be positive, the smallest must be negative. And then now we can say p minus 2 is equals to 0, or p plus 7 is equals to 0. P minus 2 is equals to 0. So find the p, we equate, take the 2 to the side, become positive 2, or in the p plus 7 is equals to 0. To find the p, will transpose the 7 to the side, then the p will become negative 7. We need the value of x, not the value of p. Now that we have the value of p, in the let of the roots x plus 5 is equals to p. Substitute now the values of p so that you can solve the value of x. So the first p is positive 2. Solve the x here. To get rid of the square roots, we introduce the squared both sides. Then x plus 5 is equal to 2 squared is 4. X is equals to, we minus with negative 5 in both sides, so we'll have 4 minus 5. Then x is equals to negative 1. There were two values of p, so we'll resubstitute again into the equation. Root x plus 5 is equals to p. So the second value of p is negative 7. Squared both sides. X plus 5 is equal to negative 7 all squared is positive 49. Then x is equals to 49. We minus with the 5 both side, minus 5. Then x is equals to positive 44. So we'll need to check if both of these values are the absolute value of the equation. So we said roots of x plus 5 is equals to positive 2. Now that we have the value of x, let's just substitute it here. Negative 1 plus 5 is equals to 2. Negative 1 plus 5 is 4. Then the root of 4 is equals to 2. So the left hand side is equals to the right hand side. When x is equals to negative 1, we'll check with the 44. Whether is x now is 44 plus 5. Then the right side is positive, is negative 7. Then 44 plus 5 is 49. Then the right side is negative 7. Then square root of 44, it's square root of 49, is equals to 7. Then we all know that 7 and negative 7 are not the same. So the left hand side is not equals to the right hand side. So we can therefore conclude that x must not be equals to 44. The value of x is negative 1. Is 3 exponent x plus 1 minus 4 plus 3 exponent negative x is equals to 0. What is the value of x? So again, with the exponential, whenever you have a base with two exponents, so the split is 3 exponent x times 3 exponent 1 minus 4. The base with a negative exponent, so it's an inverse, so it's 1 over the base become positive. 1 over 3 exponent positive x is equals to 0. The 3 exponent x times 3 is the same as 3 times 3 exponent x minus 4 plus 1 over 3 exponent x is equals to 0. The equation of a denominator, so the RCD is 3 exponent x, so multiply the entire equation by the RCD of 3 exponent x. So 3 exponent x times 3 into 3 exponent x. So this is 3 times 3 exponent x times 3 exponent x. So we keep the 3, then the same base, we add the exponent, so it becomes 2x. So now we will have 3 times 3 exponent 2x. Negative 4 times 3 exponent x is negative 4 times 3 exponent x. Then 1 over 3 exponent x times 3 exponent x. They divide, then we're left with 1 is equals to 0. Jump straight to the substitution method. So let the 3 exponent x be k. Where there is 3 exponent x, we substitute with k. Then it's 3 times, here it's k, then there's squared, meaning the k will be squared, minus 4k plus 1 is equals to 0. It's just a simple quadratic, so the factors of the equation, factors of 3k squared are 3k and k, factors of positive 1 are positive 1. Therefore, both factors will be negative, as the last term is positive and the middle term is negative. So now we'll have 3k minus 1 equated to 0. or k minus 1 is equals to 0. So 3k is positive 1. Then divide by 3 both sides. K is equals to 1 over 3. Then the k here is equals to positive 1. We're not solving for k in this equation. We are looking for the value of x. After having the values of k into the left equation, we have to substitute the values of k so that you can find the values of x. So the left was 3x exponent x is equals to k. The first value of k is equals to 1 over 3. To solve for x here, the reciprocal of 1 over 3 is equals to 3 into negative 1. The purpose is to have the same base. The same base will equate the exponent. X is equals to negative 1. Or again, into the same equation, 3 exponent x is equals to k. Then the second value of k is equals to positive 1. Any base with an exponent of 0 will be 1, so we will rewrite the 1 in an exponential form. So it becomes 3 exponent 0, therefore x is equals to 0. So these are two values of x of the equation, negative 1 and 0.